Here they're giving us epsilon is equal to 3. We're trying to find the limit of f of x as x goes to 3 is equal to 2. What is the delta value that satisfies that? So I do want to mention, like, you could look at this as this is the error that is on the y-axis. The target is 3 on the x-axis because x arrow 3, and the target on the y-axis is 2 because that's what our limit is equal to. So you could use just that given information and kind of hand wave your way through what the delta would be. But if we're going to be very precise about this and have a method to the madness, we would go back to the limit definition where we have these two inequalities, and we would plug in our C, L, and epsilon appropriately. So we would have 0 is less than absolute value x minus, that arrow becomes kind of a subtraction sign, 3 is less than delta. Then our f of x, which they don't tell us, minus L, which is 2, is less than epsilon. All right, so now we identify target and error. So from x minus 3, opposite sign, that tells us that the x target is equal to 3. Delta is what we're trying to find, so there's nothing to sit there and fiddle around with. Then our y value, the target, is going to be 2, opposite sign of what's inside that parenthesis. And then I was very remiss in this. They told us what the epsilon was. So you could actually plug in epsilon is equal to 3. So my epsilon, my error that's going to be on the y-axis, is going to be equal to 3. Okay, so with that understanding, we then look at the graph and we start off using this last part where we're going to draw our epsilon band. So our target is 2. And then in this case, we go up 3 and down 3. So if I go up 3 to 5 and then down 3 to -1. So we have a much bigger epsilon band than in the previous question. All right, so I draw the start and stop of that epsilon band. Okay. So again, the whole idea is everything in this little epsilon band is going to be what I want to stay within. And I want to find where I start and stop in that epsilon band with the function. So going from left to right here, we see that the function enters into the epsilon band here, and that corresponds to an x value of 2. It then leaves the epsilon band here, and if I go down to the x-axis, that corresponds to 4. Now, the target that we're trying to get to on the x-axis is 3. So 3 is our target, and we want to figure out the error from 3 to stay within that epsilon band. So to the left of 3, we would have to be 1 unit away, and to the right of 3, we would also have to be 1 unit away. So one way of thinking about this is you're taking 2 minus 3, that gives you 1, and then you're taking 4 minus 3, that gives you 1. And so that tells you that your delta value that you want to take would be equal to 1. So we would take delta equal to 1 to have our epsilon to be equal to 3.